Okay. We are back again for day 4 of Advent of Code. There we go. Let me just make sure we're live and everything's working real quick while we've got a minute before things actually start. Nice, cool, yay. Alright, everything's looking good. So I took the time today to set up my stream nicely and invest in like a chat overlay and a leaderboard code display on the stream so people can actually join the private leaderboard that I've set up. This is the code. It's also right on the corner here. So there you go. Cool. Advent of Code day 4 starts in a minute. As I say every day, it's a daily advent calendar through the month of December. Coding challenges that get progressively harder and harder. Yesterday was pretty rough. I did eventually get it. I stopped streaming before I did, but it was a weird regex problem, and my issue with part. So I got part 1, but my issue with part 2 that I didn't figure out on stream, but did figure out afterward, is that I just needed to ignore the new lines. And once I did that, my code worked. So there you go. Sometimes it's as simple as just not reading the instructions fully. So hopefully day 4 will be a little bit easier than day 3. I think day 3 was also hard last year, but day 4 was easier. 3 seconds. Here we go. All right. Looks like the chief's not here. Oh, look, it's me. It's a word search. Cool. Love it. She only has one word defined, XMAS. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. Okay. Don't know what this part means. A little unusual, though, is you don't merely need to find one instance of XMAS, you need to find all of them. Here are a few ways to access them here. Okay. The actual word search will be full of letters instead. In this word search, XMAS occurs a total of 18 times. It's the same one again, where letters not involved in any XMAS have been replaced with dot. How many times does XMAS appear? Okay. Okay. Cool. So this is like a graph traversal thing. We need to start at X and go in a straight line for 3 in every direction. We always need to start on the X. And we also need to count all the occurrences, including if it overlaps with another word. So like if there's 2 XMASs, like in this example, we need to count this one, and also this one vertically. So, all right, so we're gonna have to do some stuff about traversing a graph. This feels like, wow, I really have not done lead code in so long. I don't even remember how to approach these problems. I think I don't care about... I don't even really need to do like BFS or DFS, because it's only going in one direction. So, okay. So lines is just going to be our grid, basically. I'm just going to call it grid to make our lives a little bit easier. We'll do for R in grid. We'll do for row in grid. For call in row. So we'll iterate through the whole grid like this. And I think I'll want a helper method to go through like from a starting point to an ending point. Dir X, dir Y. Probably will only need one of these to ever be defined. So this function is going to take in the grid, a starting coordinate, and then which ways to go. So this will let us go, from here and then check this direction to see if it says XMAS, and then check this direction to see if it says XMAS, or go up and down. Probably we don't need dir X and dir Y. you know, to go up and down versus side to side, because we're only going one way. Oh, never mind. We do need both, because they can be a diagonal too. Just kidding. Okay, good. So we do need all that. We'll start at our start point on the grid, and then we'll go in each of these directions. But we'll actually call this from a different... We'll call this from part 1 here. We'll do, like, you know, each of the pairs for each of the corners that I can go in. And then we'll only start if grid row call is X. We will do for direction in directions, we'll do if traverse grid start direction 0, direction 1. We'll do total plus equals 1, and I haven't actually defined total yet. We can actually just return true as our default. Grid start is row call. And actually, let's just have this be, we'll call this dirvec. This will be our direction vector. And then we'll just have this be direction. It just makes our signature a little bit nicer. Cool. So then we need to define directions. So directions is going to be a list of, it's going to be 1, 1. There should be 8 of these. We'll do -1, -1. So this is going to be 1, 1, 0, 1, 1, 0. We don't need to do 0, 0, obviously. Then we need to do -1, 0. I'm not doing this in order. -1, 0. -1. -1. Oh man, I'm getting mixed up here. 0, -1. That's a new one. We haven't done that yet. 0, 1 we've done. Here, let's do this. This will be easier to order it. -1. And then we need 1, -1. -1, 1. Then we'll need 0, 1, 0, -1. And we don't need 0, 0. Cool. So this should be all the directions that we need to go in. Just for consistency, I'm going to do like that. It so doesn't matter at all. So this is all the directions that we need to search in. And then we'll do... So this is the number away that we are from the start. We'll do while I is less than. So we're starting here. We need 1, 2, 3. We will do I plus equals 1 at the end. And then if grid start 0 plus dirvec 0. This is kind of gross, but hopefully it's clear what I'm doing here. So this is checking the grid plus the offset in whatever direction we're going. And then we want to check if this is equivalent to the corresponding letter in XMAS. So we'll do XMAS I. Then we can, sorry, we want to check if it's not this. If it's not equal to the letter that we expect in XMAS, then we want to return false. And then we want to increment. We can start I at 1 because we know that we've started on X, and then we can go till while it's less than 4. So this will do 1, 2, and 3 for I, which should be correct. 1, 2, and 3. Yeah, cool. So if that's the case, then we will return true. The other thing we need to be careful of is if grid. So we'll do rows is length of grid. Right, that's the number of rows down, and calls is the length of grid 0. So we also just need to make sure that we're not running off the end of the grid in any direction. We should do new chord. New row is this. Times I. We never actually used our I there. New call is this times I. And then we want to do if new row is less than 0 or new row is greater than or equal to rows, return false. And the same thing for columns. New call. Cool. Otherwise, if this is true, or if this is not what we expect it to be, if the character there isn't what we expect it to be, we can also return false. If it is, at the end of all that, we can return true. I think this does what we want it to do. This is quite the, yeah. If you're nesting your code this much, you've got a problem. Oh man. Okay. So I think this does what we want it to do. The only thing I'm worried about is double counting, but I think we're safe because we'll only count each XMAS once, because we only count when it starts from X, if that makes sense. So we won't count, you know, if we count this XMAS from this position, we won't then count it again from this position because we only do it from X. So let's see if that does it for us. And then we will print total at the end here. Let's get this test grid 18 times, they're saying. Cool. Input. Is this, that's our day 3 input, whoops. Not what I need there at all. I need this input. So let's try this and see what happens. Python main.py. Grid row call. Oh, right. For length of grid. And then length of, yeah, we can do length of row. They should all be the same. Oh, because it's range length. Yep. Can you tell I haven't used Python in several months? That I haven't LeetCoded in even longer? Okay. Object of type int has no length. For row in range length. Oh, sure. Fine. 18. Okay, that's actually really encouraging. I think we might have gotten it right the first try. Let's see. Oh, goodness. This is a huge puzzle. All right, let's see if we get the same thing. I expect this might take a second to chug. Oh, no, it's pretty fast, actually. Computers are fast. Let's see if that's it. If it's not, I'm going to be sad. Great. Excellent. Part 1's done. Took us a bit to code, but conceptually pretty straightforward, and actually no bugs except for just my... I guess that was a bug, sort of. My syntax for doing the indexing was wrong. Did I misunderstand the assignment? I guess so. You flip for the word search, finally this isn't actually an XMAS puzzle, it's an X-MAS puzzle. We're supposed to find 2 mas in the shape of an X. The way to achieve that is like this. Holy moly. Wow, that's something. Okay, sure. You know what? Sure. So So it can go like this, but I guess it could also go backwards. MAS. Yeah, okay. So we've got... Wow, that's exciting. Okay, that's exciting. I think this is actually kind of easier. And by that I mean, if we have... So let's see... I'm just gonna draw this out really quick. So if we have an A here, all we have to check is what these corners are. And I'm just trying to figure out if there's any scenario. Oh, okay, so MAM, for instance, would not be. So like this wouldn't work, obviously, because this does not. This is MAM and SAS. So my first thought was to, every time we see an A, just get the corners and see if we have two M's and two S's. And then we would be done. Except we can't quite do that because we can't have MAM and we can't have SAS. So instead so we can still do the same thing. We can get the corners and make sure that the top, that opposite corners don't equal each other. So we'll have to like check. Start from A, get, caps lock, I guess. Get corners, make sure opposite corners not equal. Make sure two M's and two S's. And I think these are the only thing that we need. These are the only things that we need to do. So all we really have to do is, so it's very similar to part one. We can just have a different function for traverse here. So instead of going all the way along the word here, we'll have like def is crazy. And then we'll need our grid, we'll need our start, and then we don't even need a direction vector. We just need to check the corners. Check your corners. Like Black Ops 2. I feel like that was a voice line. I don't know, I'm old. Alright. Yeah, so instead of traverse, we want to do is XMAS. And then we don't even need direction. Cool. I said we don't. What the heck did I... Okay, yeah. So I did that yesterday where I went up and started modifying part one when I really wanted part two. And as it turns out, that's not the right thing to do. And I spent like a good 2 or 3 minutes trying to figure out what the heck was happening. Okay, so check corners. We'll do corners. We'll just get like a vector here. So we want -1, -1. We want 1, 1. Whoops. We want -1, 1. And we want 1, -1. Okay, so let's do for C in corners. We'll do this. We'll do M count is 0. We'll do S count is 0. So we want these to be 2. We could use a dictionary here too, but it doesn't matter. For C in corners, we'll do start 0 plus C0. We don't even need to do times I. C1. And then we can do most of our similar validations here. Obviously, if we go off the end, we are going to return false. Because this is not, it can't be an X if it goes off the end of the grid. And then this is going to be our real check. it's not in MS. We can return false. So sorry, this now is going to be a real check. And then we'll do if it's M, we'll do M count plus equals 1. And then if it's S, we'll do our S count plus equals 1. At the end, we need 2M, 2S, and opposite corners not to match. So we need return M count equals S count. Can we do this in Python? Totally we can. That's super cool. We need those to equal 2, and we need... Oh, this is kind of messy, but I think it makes sense to do it this way. And -1, 1. Oh boy, great. Yikes. Start plus 1. Start plus 1, not equals grid. -1, -1. And also further, -1 plus 1 and +1 -1 cannot equal each other. So that's a really exciting if statement. Let's split this into 3 lines so that we can see more or less what's going on here. Cool. I feel like it's gonna get mad at me for indentation, but we'll see. All right, let's try this. We'll put our input back to what it was before. Come on, there we go. Meaning this first one. Whoa, that's not what I want. This is what I want. So 9 times, they say. All right, let's see if we get 9. No, we actually don't. I guess we've got to print out total at the end here. 0, excellent. Okay, cool. So, where are we going wrong? Whoa. Oh, because we're starting at X. We need to start at A. Still not that. 4 direction and directions. Oh, because like I said before, I'm modifying part 1 instead of part 2. Can only concatenate tuple, not int to tuple. Why does it think we have a tuple? Total 0 and grid. Start corners. Oh, start 0. Oh man, wish I hadn't done that. Start 1, because now I've got to replace all this. Yeesh. So what happens when you copy paste all your code is if you make a mistake, it's a bad time. Start 1. This has got to be start 0. This is, well, that's exciting. That's why you don't copy paste, kids. 9. Cool. All right. So that seems to be what we're looking for. Let's see if it works for our actual input. 1351. Oh! Not correct. Interesting. How? Alright, well, that sucks. Let's see. Where could we be going wrong? I feel like I'm missing... Oh, hold on. Wait. MM... SS. No, that would work. Flip the word search from the instructions back over to the word search side again. Flip the word search from the instructions back over to the word search side. Oh, I see, I see. This is just, this doesn't mean anything. It's just do the same thing again. 2 mas in the shape of an X. We'll treat this like this. Okay. So I'm wondering, wait, did it actually say if it just says we don't have the right answer. Sometimes it tells you if you're too high or too low. So it's almost certainly somewhere here. New call, new row, new call. If it's not in MS, start 0. Start 0, -1. So this is right? Like this is -1, -1. This is 1, 1. This is -1, 1, and this is 1, -1. -1, 1, 1, 1, -1. -1, 1. Oh, start 1. Start, no. Yeah, no, that's right. Start 0. I think that might be our issue. 1900, and what if we go back to here? Is it still 9? Okay, cool. So let's try 1900, because that was definitely a typo. Correct. There we go. I meant to say great there, but it kind of came out as grit, because I'm bad at talking. Okay, anyway, yay, we did it. Our approach was solid. It ended up just being a typo. That's what, again, that's what you get when you copy code with Control-C, Control-V. Cool. That was not so bad compared to day 3. That's kind of how I remember it. That's kind of how I remember it being last year, where day 3 was really rough, and then day 4 is easier again. Let's see how we did on our leaderboard. Oh, look, we're back in first place, baby. You like to see it. Nice. Yeah, so nice little kind of graph traversal problem. Not actually too big of a deal. Like I said, yesterday was harder, I think, because I'm really bad at regex. I think if I knew how to do regex, it wouldn't have been nearly as bad. It seemed really solvable if I had just used only regex and knew how they worked enough to do that. But anyway, not too bad. 20-ish minutes, 25 minutes for day 4. I will leave it there. I'm going to go to sleep because I'm tired. Whoops, that's not what I wanted to do. Thanks for tuning in today. I actually won't be online tomorrow at the exact time. I'll probably be about an hour and a half late 10:30 or so. I've got something going on tomorrow and then next Wednesday. But yeah, stream will be just a little bit later. I'll still hop online and do it. Anyway, see you tomorrow.